Hello, Math 2. This is Mrs. Bricky, and this video is for Unit 8, Lesson 4. This video will just be for the Part A, first part of that lesson, and then there'll be a separate video for Part B. Today we're going to start working more with quadratics in standard form, and we are going to start with some vocabulary. So, axis of symmetry. We have talked about how parabolas are symmetric, and that line that imaginary line that would sort of cut that parabola into two mirrored parts that are identical is called the axis of symmetry. The axis of symmetry, of course, would always pass through the vertex of the parabola. So the vertex is that on this parabola, that minimum point. So your axis of symmetry goes right through the vertex and sort of cuts that parabola in half. We can use the x-coordinate of the vertex to write the equation of the axis of symmetry. So on this parabola right here, it's a reflected parabola. You can see the vertex right here at the point 2, 1. Well, the axis of symmetry is a vertical line with the equation x equals 2. The axis of symmetry is the x-coordinate of the vertex, so x equals 2. From a graph, it's easy enough to see what that axis of symmetry is. The other vocabulary word that we want to work with today is the extreme value of the function. An extreme value of a function is either the highest value or the lowest value of the function. So the highest value is called the maximum. If the function has a lowest value, it's a minimum. So parabolas have one or the other, but not both. So this parabola function f right here, it has a minimum. Oh, I can spell minimum. Try that one more time. Minimum value of 2. So when you're thinking about the minimum or maximum value, you're thinking about how high or how low does that parabola go. This one, the lowest it goes is a y value of 2. Extreme values are always y values. So the vertex tells us two things. It tells us the axis of symmetry. The axis of symmetry is the x value of the vertex. And the extreme value we can get from the vertex as well. It's the y value of the vertex. And you'll just have to think about if it's a min or a max based on whether the parabola opens upward or downward. Okay, so this function g, it is a reflected parabola, so it opens downward. The function g has a maximum value of 7. 7 is the highest that parabola goes. Okay, so we have graphed parabolas in vertex form before, but we're going to review that a little bit right now. And then we'll look at intercept form for one review, and then we'll get into standard form. So for vertex form, our parabola function looks like this. In vertex form, the thing that is the most easy to learn about the parabola is the vertex, and that's why it's called vertex form. So for our function f that we're going to graph right here, we're going to look for the location of the vertex in that equation. And just remember with your x value, the one that's grouped inside the squaring, we're looking for the x value that makes this group this binomial 0. So you see the 3 is there that you see, but the x value of the vertex is -3. But the y value is what it is. The equation shows it, and it is what it is. So the vertex of this parabola is going to be at -3, -6. So here's the vertex. We'll plot that point. This parabola, if I'm going to finish graphing its shape really quick, it has a stretch of 2. So that means that the 1, 3, 5 pattern that I use to graph it is stretched by a factor of 2 or is doubled. So I'm going to graph up 2 and then up 6 and then up 10, but usually the 10 won't fit. So up 2 over 1, up 6 over 1, And then I'll do that other symmetric side. Okay, so our parabola looks like, oh, it's so shaky. Sorry. It's hard on a tablet. So here's our adorable little parabola. So we're going to answer a couple of other questions here. The axis of symmetry, remember, is that line of symmetry that sort of cuts that parabola right in half. It's x equals -3. The extreme value of this function, this one has a max. Oh, sorry. Haha, not a max. It has a lowest value. It has a minimum. I was just seeing if you were paying attention. A minimum value of -6. The y-intercept of this function, now it doesn't even show on the graph, so we can't just pull that number off of the coordinate plane. If you ever need to know the y-intercept and you can't see it visually on your graph, that just means you sub in 0 for x in your function. So f of 0 is 2 times 0 plus 3 squared minus 6. And you can calculate that in your calculator if you want, or if you like to do these sort of calculations in your head, you can. So our y-intercept would be 2 times 9 is 18 minus 6 is 12. And that kind of tracks on our graph because right now, like right at this point, we're at a height of 2, and the next part of our pattern would be to go up 10, so that would put us at 12. So that sort of matches what we have on our graph, even though we can't see the y-intercept. Okay, our x-intercepts. Well, I mean, my graph is not that great of a drawing, but you can kind of see that the x-intercepts they're not at integer values, no matter how bad my graph might look. The x-intercepts are between -1 and -2, and between -4 and -5. So we need to solve the equation to find the exact location of those x-intercepts. So we're going to take our function and we're going to set it equal to 0. And we're going to solve for those x values. The reason we set it equal to 0 is because they are called the zeros of the function because it's where that function has a value of 0. So let's solve this. We practiced this last class. It is going to be the square root method of solving. So we have 2 x plus 3 squared is equal to 6 when I added that 6. Now I'm going to go ahead and divide by 2 on both sides of my equation. That leaves me with x plus 3 squared is equal to 3. Now I'm ready to apply my root. I'm just going to scroll down a little bit here. So we're going to apply a root to both sides of our equation. When you apply a root to both sides of your equation, don't forget that there are two numbers on the right side of your equation, a positive and a negative. So we need to put a plus or minus symbol there. So we have an x plus 3. We used the root to undo or cancel the power, so we just have that x plus 3 left on the left side. And the square root of 3 doesn't simplify, so I'll leave it in that form. And then my last step is that I need to subtract 3. So x equals -3 plus or minus root 3. Those are our two x-intercepts. Now, I think it's interesting to note that your axis of symmetry totally shows up right there. It's saying that those x-intercepts are kind of centered at -3. The one to the right is -3 plus root 3. So that's this one. And if you calculated that in your calculator, that's approximately -1.27. And the other one is -3 minus root 3. So it's going backwards by root 3. That would be this one. And that a decimal value, if you calculated it, is 4.73 approximately. And those are rounded to the nearest hundredth. So we found our two x-intercepts. So that was vertex form. So now we're going to look at and review standard form. So vertex form is when our function is making the vertex very visible to us. Intercept form is where the function is in a factored form, which shows us where the x-intercepts are. So if you have your factors, make sure that, if you have a factor of x minus p, that's going to put the intercept at positive p. So you always have this sign change happening because you're thinking about what x value makes that 0, and the x value that makes x minus p equal to 0 is p. So if I have the function f of x equals negative x minus 2 times x plus 5, I am going to have x-intercepts at negative 2, oh my goodness, at positive 2 and at negative 5. So I already have this graph kind of sketched for us with those two x-intercepts shown. If you are working with intercept form, parabolas are symmetric. So if we're looking for the axis of symmetry, we can just add together those two x-intercepts and divide by 2. We're basically finding the average of those two intercepts. So in this case, to find the axis of symmetry, it's going to be x equals negative 5 plus 2, and we're going to divide that by 2. Now I'm going to go ahead and put it in a decimal form, negative 1.5. Sometimes with decimal form, it's easier to get it on the graph. So it's not at a whole number, and that's okay. It's between the negative 1 and the negative 2. So I'm just going to sketch that in. And so we're looking for the vertex. Well, the vertex is right here. We know its x value is negative 1.5. We need to know its y value, though. So to get the y value, we're going to sub in x equals negative 1.5. So f of negative 1.5 is equal to, so we've got a negative at the beginning of our function, then we have our x value minus 2, and then we have our x value plus 5. And we can calculate that in our calculator. And if we calculate that in our calculator, we get 49/4. And if you had that in decimal form, that would be okay as well. I'm going to leave it as a fraction, but you definitely could put it into decimal form. So now that we know the location of the vertex, we can find the extreme value. The extreme value is the highest value on this function. It has a maximum. So this one is a maximum value of 49/4. It's the y value of the vertex. Okay, the last thing that we want to find here is our y-intercept. The y-intercept occurs when x equals 0, so we're going to sub in x equals 0. F of 0 equals negative. Our x value is 0 minus 2, and then our x value of 0 plus 5. So if we calculate that, we get that the y-intercept is positive 10, and you can crunch that in your calculator if you want. So our y-intercept is 10. All right, so that was a review of intercept form and how the axis of symmetry works with intercept form. That is it for part A. So if you're doing your paper assignment, you might want to try some of those. There's 3 problems on the front side of that, and just let me or your teacher know if you're having any problems or you have any questions. Thank you.